Hey, good morning, everybody. This is Mr. Ainsworth here at Great Oak High School in AP Pre-Calc here, and we are in our last lesson in 8.5. We're going to be talking about the rates of change of polar functions, and we're going to put everything together that we've learned in the past about how functions increase and decrease on certain intervals, and put that together with polar functions. So the goal here, if you just read with me, is to determine the conditions on which the distance of f of theta, which is the radius of a polar function, and the origin is either increasing or decreasing, and how it's related to the fact that on certain intervals the function is either increasing or decreasing, and it's either positive or negative. Okay, so what we're going to do is put everything we've learned about graphing and analysis together, and we're going to compare what's going on with the function in two different ways, in the rectangular form, as you see on the graph above, and then on polar form in the graph below. And notice that this table of values, this comes from the same function, so they're the same. But again, on the top, you're talking about rectangular form, uh, and then on the bottom, polar form. So here we go. Let's get right into it. The function that we're going to be working with right now is f of theta, or r, equals 1 plus 2 sine theta. And in rectangular form, it's written as y is equal to 1 plus 2 sine x, where the midline is the k value, the midline is 1. Okay, and you can see that in the graph. You can see how if you draw the horizontal line at y equals 1, it goes right through the wave. We got an amplitude of 2. Okay, so notice that it's 2 units above the midline. Okay, so that's why it goes up to 3. And then it goes 2 units below the midline down here at -1. So you can see how everything you learned before kind of applies here. In reality, in our homework here, you're going to have to sketch this on your own without Desmos here. This is an instructional video, so I produced it for you. And then I evaluated the function at many angles from 0 to 2 pi, as you can see in the table. And the points on the graph that are labeled in red, okay, are the points in the table, so they go hand in hand. Okay, obviously I produced this in Desmos. So what we want to do is first, and this is the easy part, is determine the intervals where it's increasing or decreasing on an interval, and where it's positive or negative. And where it's positive, it's going to be above the x-axis, okay, and negative, it's going to be below the x-axis. Okay, so this is what we know from prior units. I'm talking about back in first semester when we started learning where functions are increasing and decreasing and whether they're positive or negative. So this is the easy part. And then afterwards, we're going to take the same function in polar form and analyze where the distance is changing, on what intervals the distance of the radius, or from the f of theta to the pole, which is the radius, how it's changing. Is it getting farther away from the pole, or is it getting closer to the pole? Well, there's a connection between whether the function's increasing, decreasing, and positive, negative, and the distance from the pole. So the only way you can see that is by analysis. So here we go. Let's figure out on what intervals is it increasing or decreasing. Okay, so here we go. From 0 to the max. Okay, so where does the max occur? It occurs up here at point A. We'll call this point A. And guess what? That occurs at pi halves. So that's a critical point. So in this interval here, from 0 to 2 pi, ooh, let me decrease the size of all my colors here. Jeez. Okay, so from 0 to pi halves, all right, the function is going up. Look at this, it's going up, right? And that means the y values are increasing, okay? And notice that it's above the axis. So that means that it's increasing, okay, and positive. Okay, and that is on the on the interval from 0 to 2 pi. So it's increasing, okay, and positive on the interval from 0. So theta is between 0 and pi halves. And if you want to write it in interval notation, you just go 0 comma pi halves if you want. Okay, so from that point, things change, because at a max it goes up, okay, it increases, obviously, and then it goes down, right? That's how you get a max. So on the other side, okay, on the other side of the function here, it's going down, so it's obviously decreasing here, but it's still above the x-axis, right? So because of that, okay, all the way up to 7 pi 6, it's decreasing and positive. Okay, so from here to here, from pi halves, all right, pi halves less than theta less than 7 pi 6, all right? Or you can, again, you could write it as an interval. So if you want to, if you prefer that, that's fine. Okay, it's decreasing and positive because it's going down and it's above the x-axis. So decreasing and positive. Okay, then after that, after 7 pi 6, it changes because now you're below the axis. All right, so it's still decreasing here to the minimum. We'll call this point B just for reference so you know what I'm talking about because you can't see my hands. All right, and that's a minimum, right? It's the lowest point, so we call that a minimum. And so that occurs right here at 3 pi halves. So I'm looking at all the critical points where things change at mins and maxes, but also at the intercepts too, because that's where it either goes it's either above the axis or below the axis. So when you're below the axis, the function or the y values are negative, but it's still going down. So between these two in this interval here, from 7 pi 6, all right, to 3 halves pi, okay, you can see that the function's below the x-axis, so it's negative. And it's also going down, so it's decreasing. So it's decreasing negative. And as I'm going through here and illustrating what's going on here, you got to be thinking like, how is this related to our goal? Like we're trying to figure out, if you look at the top of the screen, on what conditions on which, or we're trying to determine the conditions on which the distance from alpha theta to the origin, which is the length of the radius, okay, this right here, it's called the radius, the length of the radius, the length of the radius. That's R. Oh, okay. How is that changing? Is it increasing or is it decreasing? How is this related to it? And the only way you can see that is if you take a look at the function in polar form, which we're going to do here in a minute. We're going to put the two and two together. Right now, we're just taking skills that we already know, because this is in prior units, and analyzing the function. All right, so we still have a few more to do. Okay, so from 3 halves pi to 11 pi 6. Okay, there's an intercept right there. So in this little interval right here, so from 3 halves pi to 11 pi 6, all right, what's going on? Well, it's going back up. Okay, so it's got to be increasing. The y values are going up, so they're getting bigger, and it's increasing, but you're below the x-axis, all right? So it's negative, okay? So it's increasing and negative, increasing and negative. So I'm just writing down my observations. And then we're going to put the two and two together. Okay, and then my last interval is from 11 pi 6 to 2 pi, this little interval here. But notice that we're increasing because we're going up, all right? But we just jumped above the x-axis. So now the y values are positive. So from 11 pi 6, my last interval, to 2 pi, because we're working on the from 0 to 2 pi, so that's why I'm stopping at 2 pi. All right, we're increasing and positive. How is this related to the distance of the radius or the distance from the point to the pole? And how is it related to the fact where is it going away from the pole as we're going from 0 to 2 pi? Or is it getting closer to the pole? How is that distance changing? And that's what we want to figure out right now. Okay, so what we're going to do is we're going to take a look at our first interval here. So our first interval is from 0 to pi halves. And so what we want to do is take a look at what happens on the polar function. Okay, so what I'm going to do to help you guys see things, because you can't see my hands here, is I'm going to label the points A, B, C, and D, and we're going to plot these points in order. Okay, so, but before I do, you have to understand that in the table, this is theta. In the previous one, we have x comma y. I forgot to write that down. And our function was y is equal to 1 plus 2 sine x. Okay, this is rectangular form. When you graph it on a regular XY plane, and notice this bunch of rectangles here, this is in rectangular form. But when you graph it in polar form, which is what you're looking at here now, you input theta and you get r out. And then when you graph your point, it's always r comma theta, as you guys know. So my first point here that I need to plot is 1 comma 0. Okay, where's that? Well, it's right here. Okay, so I'm going to call that point A. Again, I'm just going to label these in order. So A, B, C, D, And then I'm going to stop at E here just because this is my first interval. All right. That's my first interval. So I'm using the same intervals from above. Okay. And I noticed that I just put them in different colors. Maybe I should put them in the same color. So maybe that was purple. Okay, so first interval is in purple. So let me change this just to be, color coded, right? Not that it matters. Okay, so A, B, C, D, E. First interval. What's going on? Is the distance from the point to the pole increasing or is it decreasing? Remember the goal, okay, at the top of the screen. Determine the conditions on which the distance from the between f theta and the origin, which is your length of the radius, is it increasing or decreasing? When does that happen? That is the goal. So on our first interval from 0 to pi halves, what's going on? Well, to see that, you just plot. Okay, so 1 comma 0 is at point A. B is 2 comma pi halves, or pi 6, excuse me. So 2 comma pi 6. So this is point B. 2 comma pi 6. Okay, and then the third one here, C. I'm just using red on the graph here just so you can see it better, guys. So sorry. Um, and then 2.4 comma pi fourths. So this is pi fourths. 2.4 is a little bit greater than 2, right? So it's got to be here. Okay, so that's C. And then D is 2.7 comma pi thirds, which is here, D. And then E is at the top here, 3. So this is at 3. Obviously, this is 1 here. So 1, 2, 3. You're on the third concentric circle. Or well, don't count the circles, okay? Because they just go with how it's labeled here, okay? Um, and then you're at point E up here. So what's going on with the radius? So what you do is you draw it. So the length from the pole, or the distance from the pole to the point is what we're concerned with right now. So the pole is here, obviously. Okay, the pole is the origin, right? Okay, so you guys know all this stuff. And the distance from the point to the pole, from the origin to A, that's called R. Okay, so there you go. Is it getting longer or is it getting shorter? Is this point moving further from the pole or closer to the pole? So here's the second radius right here. And then here from pole to point D is the next radius. Oh my God, look at that. It's getting longer from A to B to C to D all the way to E here. All right. So from A to E, all right, the distance or the radius is increasing. Okay. So I can say the distance, but I can also say the radius is the same thing. So the distance from point to pole from f of theta, which is your point, right, to pole is increasing because you're getting further away. So I'm going to write that down here. So distance in this first interval from point to pole, distance from pole is increasing. I'm going to write down my observations. Okay, that's the first one. And you wouldn't be able to see that from the graph in rectangular form that we analyzed in the beginning. You can't see that, right? Because you're not in polar form. The only way we can see that is in polar form, and that's why we have two graphs. Okay, now on our next interval, if you look at in green here, we went from pi halves to 7 pi 6. So that's green, so let me switch to green. All right, so all the way to 7 pi 6. There's my next interval right through here. All right, and what's going on? So let's figure this out. So F, E, F, G, got to go in order, right? G, I can go through the alphabet here. Feel like I'm in grade school. All right, from F to J, what's going on? So again, this point right here is 2.7 comma 2 pi thirds. Okay, so that's F. So where's F? So F has got to be where this ray from these rays right here coming out from the pole intersects the graph, right? So this is point F up here at 2 pi thirds. Excuse me. Yeah, I said that right. And then here 2.4 comma 3 pi fourths. So this is 3 pi fourths. It's a good thing we know the unit circle, right? Okay. Okay, and that's G. And then H. H is at 2 comma 5 pi 6. That's got to be H right here. And then 1 comma pi. That's got to be here at I. So there's I. And then J. Okay, what is this crazy number that decimals produced? All right. Well, when you have 4.4 times 10 to the negative 16th, that's scientific notation, guys, and I don't know why, specifically why decimals can't put zero there, but if you move the decimal place 16 units to the left, okay, that number is so small, it's zero, okay? There's got to be something going on inside the software. I don't know why it's not expressing it as zero, but these numbers here in the table are equal to zero. So what we want to do is we want to plot 0, 76 pi, and guess what? That's at the pole. When the radius is 0, you're at the pole. Okay, and so J is right at the pole. So let me squeeze it in here. There we go. All right, so what's going on with the distance from the point to the pole? So from E to J. So you're going this way. Okay, you're going in a counterclockwise direction. All right, so from E to the pole is your max distance. Okay, so at E, you're at max distance away. And then from the pole to F, look at green now, there's the radius. So it's obviously shorter. Okay, so there's R right there. And at G, oh, R is shrinking. And then at H, oh, it's shorter. Just visualize this, okay? R is shrinking because the points are getting closer to the pole. If you just cruise along here, oh, I forgot to draw arrows in the beginning. Okay, look at my direction now. You're cruising towards the pole, and at J, you are at the pole. So from E to J, right there, from E to J, all right, you're cruising towards, you're going towards the pole. Okay, it's going, all right, towards, I'm just going to write it in plain words right now, towards the pole. All right, what does that mean? It means that the distance, okay, ooh, gotta spell that right. All right, the distance, all right, from the point to the pole, from pole is decreasing. That's what it means. If you're getting closer, then the distance is decreasing, right? Previously, and I forgot to draw the arrows. Darn. Okay, look, I'm going to draw them in. You're cruising from A to B to C. Okay, you're obviously going further away. Okay, it's like imagine you're walking along this polar curve and you're going from the pole to A to B to C to D to E. You're going away from the pole, going away from, all right, the pole. I should have said that initially and drew the direction here. So arrows will really help, all right? But at E, you're at max distance, okay? Max distance right here. Okay, you guys know that we talk about that in class. Um, And then that's where sine of theta is max at where theta is pi halves, and that's why you're up there at point E. But then you go follow the green arrows here, from E to F to G. Well, guess what? You're getting closer to the pole because you're approaching the pole, and that means the distance is decreasing. So let's add that to our diagram up here. Okay, so this tells me now, oh, green, 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 green. Distance, okay, from pole, make sure you be specific here, from pole, not just distance. Okay, distance from pole is decreasing. Is there a connection between the fact that uh, the functions, decrease in positive with the distance? Or in the first interval, it's increasing in positive. Is there a connection between the distances increasing? Is there a connection there? And I keep on saying that because there is a connection and we got to figure it out. That's the whole point of the exercise. Okay, so now we got to keep on analyzing, right? What's our next interval? The next interval is from 7 pi 6 to 3 halves pi. So what color is that? That's in red. Okay, so now I could use red. Okay, so what was that again? 7 6 pi to 3 halves pi. 7 6 pi to 3 halves pi. Where's 3 halves pi? Okay, and here. Okay, so K, the next point is K, L, M. Okay, so where is this? Ooh, now this is a little tricky. Now the radius is negative. So now for K, it's negative zero point 0.4, comma, 5 pi fourths. Okay, we got to be careful here because the radius is negative. Now that means we plot zero point 0.4, comma, 5 fourths pi, and then we reflect it. Okay, so where's 5 fourths pi? It's down here, 5 fourths pi. And over here, 7 fourths pi. Okay, So 5/4, 0.4 comma 5/4 pi. Oh, gotta erase this right here. We gotta be able to see. Okay. Uh, okay. So point four. So where's one? One unit is on the second circle. Half a unit is on the first circle. This is a little before that. Okay, so it's right about here. Okay, so this point right here that I'm illustrating is point 0.4 comma 5/4 pi. Okay, so that first of all. So I'm just going back to basic graphing here. Now this is positive when r is positive, but when r is negative, you reflect that. So it goes from quadrant 3, you're in quadrant 3 right now, to quadrant 1. Okay, so I got to go on the other side. And so it's got to be right here. So that's what letter is that? That's K. Okay, so now we go from, look at this, let's show direction here. So we're at J, now to K. So to go from J to K, guess what? We're going away from the pole. Ooh, I already can see it. All right, now where's L? Okay, L is at negative 0.7 comma 4/3 pi. So now you're on 4/3 pi, you're in quadrant 3, but then you reflect it, and now you're in quadrant 1, up here at pi thirds. So pi thirds is, well, you can see that on right here. So now, so you're here now, okay? So look at that big red dot right there. That's L. So you went from K to L, and notice that I'm getting further away. And then negative 1 comma 3/2 pi, you're at M right here, and you're on the y-axis. And notice you're getting further away. So you're on the inner loop right here. So in through here, you're on the inner loop, okay? And you're getting further away from the pole because you're going from J to K to L to M, which is your max distance of the loop. So you're getting further away from the pole. So let's add that into our diagram. Okay, so here, so what do we have? We have distance, all right, from pole is increasing in that little interval. Okay, so now you're at the top of the inner loop. Now what's going on? We're at point M, and all we have to do is do this a few more times. So now I'm in light blue. Okay, so the next interval is from 3/2 pi to 11/6 pi. Okay, so right here. What's going on in through here? So we're at MOP. So from O. So where's O? So here you're at negative 0.7 comma 5 pi thirds. Now 5 pi thirds is in quadrant 4. Okay. Uh, Meaning if it's positive there, so 0.7 comma 5 pi thirds would be, zero point 0.7 would be a little bit more than 0.5, would be right around here. Okay, this is 0.7 comma 5 pi thirds. All right, but you got to reflect that. So you go from quadrant, oh, why did I say 3? I meant 4. You're in quadrant 4, but if you reflect that, you're in quadrant 2, which is up here, because you go in the opposite direction. So now you're up here. Okay, so this is you're up here at uh, two-thirds pi. So two-thirds pi. Okay, so but let me see, what point is that? That's O. Okay, so MO. Got to go in order. And then at P, where's P? P is right here. Okay, and so you're going from M to O to P, and guess what? You're going down and you're approaching the pole. Okay, and then at 2 pi, 1 comma 2 pi, 1 comma 2 pi, you're back to point A again. So here, but just notice if you're going from M to O to P, you're getting closer to the pole because you're on the inner loop, but you're approaching the pole again. And then 11 pi 6, you're back at the pole. So this is at the pole, and that's OP. Uh, what letter's next? I forgot. OP, Q maybe? Okay, let's go Q. So Q, you're back at the pole. All right. And so if you're going towards the pole, guess what? The distance is decreasing. So in that interval, let's add that in. So what this is telling me that the distance from pole, okay, is decreasing. And we only have one more. interval to do. So from 11 pi 6 to 2 pi, what's going on? That's my last little interval right here. So I'm going to switch to orange. All right. So let me see, 11 pi 6, our last one. So 11 pi 6, you're at the pole, and then where's 2 pi, 1 comma 2 pi? Okay, so 1 comma 2 pi. Okay, and guess what? That's the same point as A. So you're going here, watch this, from Q to A. You're getting further away, right? Okay, so further, you're going away from pole, going away from the pole. And the reason why we're connecting these two graphs is because you wouldn't be able to see this with just a rectangular graph because there's no pole, guys, okay? You can only see it in polar form. So from the pole to, or Q to A on our last one, this is point A now, from here to here, right? You're going away. So R is increasing, okay? R is increasing, is increasing. All right, so let's add that into our diagram here. So what does this tell us? It means distance from pole is increasing. And now we can summarize everything. Okay, so here we go. So these are the conclusions here that I just wrote down in the graph above. And now we just need to summarize. Okay, so on our first interval from 0 to pi halves, check this out. When it's the function's increasing and positive, the distance increasing. Okay, and here we go. Let's just analyze what's going on. So on the first one here, the function was positive because it's above the axis. It was increasing, and the distance from alpha theta and the origin, which is r, okay, what was going on? Well, it says, oh my gosh, the distance from the pole was increasing. So the distance was increasing. Next interval from pi halves to 7 pi halves. Okay, we saw in the diagram that the function was decreasing and positive, and the distance was decreasing. Okay, so it's decreasing and positive, and the distance was decreasing. Okay, next interval, we saw that, and this is in red now, third interval, we saw that the function was decreasing and negative, and the distance was increasing. Okay, so it was decreasing and negative, okay, and the distance was, what did I just say? It was increasing. Okay, so increasing. And then on the next interval from 3 halves pi to 11 pi 6, this is in blue. Okay, we saw that the function was increasing and negative, and the distance was decreasing. So increasing negative, the distance decreasing. So increasing and negative, and the distance was decreasing. And the last interval from 11 pi 6 to 2 pi, okay, in orange here, the function is increasing and positive, and the distance is increasing. So it's increasing and positive, and the distance was increasing. So let's put this all together and summarize what's going on. And there's got to be an easy way to remember this stuff because that's part of the goal in learning is you would just want to have it memorized. And so what's going on? Where is it? Where is the distance increasing? So it's here. Okay, this one. Okay, and this one. Okay, so what are the conditions? So to where the distance is increasing, okay, let's talk about that first. We have two possibilities. Okay, we got this one, and we've got this one. Okay, and then in this case, if you're positive increasing, the distance is increasing, or if you're negative and decreasing, the distance is increasing. So basically, the signs have to match. Okay, so positive and increasing going up. Okay, it's the distance is increasing, going up. Okay, if it's negative, okay, and going down, it's kind of like similar. So when the signs are the same, the distance is decreasing. That's how I remember it. Okay, so let's put that together. Okay, so when f of theta r is positive, okay, and increasing, okay, or on number 3 here, negative and decreasing, okay, distance here from f of theta to the origin or the pole which is the radius, okay, is increasing. Okay, you're going away from the pole. In other words, going away from the pole. There we go. Next one. Let's see here. So what else is going on? On number two, okay, if you're positive and decreasing, okay, so if it's positive and decreasing, so it's like the signs are different here. You're going away from the pole, or excuse me, you're getting closer to the pole. Okay, the distance is decreasing. So if the signs are different, like on number four, if you're negative and increasing, that's different signs. Like right there, you're going down. You're going away from the pole, or excuse me, the distance. Oh, going away from. You're getting closer to the pole. Okay, you're going towards the pole is what I was trying to say. Sorry. Okay, so if the distance is increasing, you're going away from the pole. If the distance is decreasing, you're going towards the pole. Okay, so let's write that down. So in number two up here, you're positive and decreasing. Okay, positive and decreasing, positive. Okay, and decreasing. Or number four, you're negative and increasing. Not you, but the function. Negative and increasing. So if the signs are basically different, okay, the distance, all right, from alpha theta and the origin or the pole is decreasing, which means you're going towards the pole. I'm just going to put this in basic words so you can visualize it. Okay, you're going towards, all right, the pole or origin. That's what it means. Okay, so now let's apply it, okay? And I'm just going to do this one last example, and then I'll do the rest in part two video here, because I don't want to make the videos too long. All right, this is just the main instructional video. So now let's apply it. And this is what you're going to have to do in your own work and in your homework here. All right, so in this case, I give you a new function. R or f of theta is 2 plus 2 cosine theta. So I switch the functions here a little bit. You know that a and b are the same, so a equals b. Okay, you have a cardioid. And notice that I didn't give you the graph. You have to do that on your own, right? Cardioid. And it's cosine, so you're symmetric about the polar axis. I'm just writing down some notes from prior lessons. Okay, polar axis here. So you're going to have to draw the cardioid on your own, and then you're going to have to graph the function in rectangular form on your own, and then answer the questions. So this is more realistic, because in the lesson here, I gave everything to you, right? Because it was an instructional video. Okay, so let's go through it here together. All right, so what do we have? Let's graph in polar form first. Okay, so let's do some analysis here. So when theta equals 0, okay, r is equal to 2 plus 2 cosine of 0. Cosine of 0 is 1 times 2 is 2 plus 2 is 4. Okay, so 4 comma 0 is on the graph. So 4 comma 0. Where is that? Well, it's over here. Actually, let me plot in red so you can see things better. Okay, so there we go. So there's your max distance right here. I'll substitute in pi halves just for funsies right now. Let's get some points going. So, and this is what we've done in class extensively. Okay, so you put an angle in, that's your input, and then you get a radius out. Okay, and then you plot your point. Or you can remember the basics of a cardioid. Okay, you can do it that way too as well. Okay, cosine of pi halves is 0 times 2 is 0, and then plus 2 is 2. So 2 comma pi halves. So 2 comma pi halves would be up here. Okay, and it's symmetric about the polar axis. So I know another one is down here because you reflected across the polar axis. And then I'm going to substitute in another point just for funsies right here. So, and not only that, it's important to know where you get the minimum too. So I think it's important to plug in substitute in pi. So r is equal to 2 plus 2 cosine of pi. Cosine of pi is negative 1 times 2 is negative 2 plus 2 is 0. So 0 comma pi is on the graph, and guess what? There's your pole. Okay, and the cardioids, as you guys know, go through the pole. So now we have enough points. Okay, so now we draw our polar curve. Okay, so let's do this. Okay, you got to put the sound effects in. There's your cardioid. All right, and notice it's symmetric about the polar axis. Okay, dokie. All right, now we use our prior skills from prior lessons. Okay, so on this one here, we have rectangular form. So y equals 2 plus 2 cosine x. We know the midline's at 2. All right, so we have 2, we have y equals 2. There's your midline. Okay, the amplitude. So this is k. K is 2, that's your midline. Amplitude is 2. So it's got to go up to 4, because remember, this is amplitude. Gives you, the max height. So I'm going to draw our guiding lines here. And then if you go down to using the amplitude, all right, it can't go below the x-axis. All right. And as you guys know from cosine starts at a max. So it starts up here at 4, then hits the midline, then down at pi, and then hits the midline and back up to the max. Thank God we did all those masteries before. Okay, so that is a graph of y is equal to 2 plus 2 cosine x, okay, in rectangular form. Okay, so now that we have that, it's easy to analyze. Here we go. So again, this is pi right here. So from 0 to pi, the function's going down, so it's decreasing. So it's decreasing here. And guess what? It's above the x-axis, so it's positive. So when the signs are different, you know that the function is going away from, or the distance is decreasing, okay, which means it's actually getting closer to the pole. All right, so from 0 to pi, so let me see, on the x-axis, we start at 0 here, and then we're going to go this way and to pi. And if you'll notice that if you draw some arrows from 0 to pi, all right, notice that the function, if you're just cruising along the polar curve right here, you're getting closer to the pole. All right, so decreasing and positive in terms of looking at the function in polar form means that the distance, all right, from the pole is decreasing. So that's number 4. So from 0 to pi, all right, the distance, okay, the distance from the f of theta to the origin or the pole, all right, is decreasing. You're getting closer. All right, you're going towards the pole, in other words, going towards the pole. All right, how about the other one? What about from pi to 2 pi? Well, from pi to 2 pi, something else is going on. You're going up now. Okay, look at rectangular form. Okay, so it's increasing, and guess what? It's above the x-axis, so it's positive. And when it's increasing and positive, it's got to be, the distance has got to increase. And so that's happening right through here. So you're going away from the pole from pi, from 0 comma pi, which is the pole, all the way to 2 pi. All right, so the distance is increasing. Distance is increasing here. Okay, and that's from pi to 2 pi. Okay, and there we go, and that's it. And that's what you're basically going to have to do by yourself. You're going to have to graph functions using prior skills in rectangular form on the xy plane. Then you have to sketch it, on the as a polar function on the polar grid. All right, and then be able to tell on the intervals where the distance is either increasing or decreasing. All right, so now it's your turn. All right, so get into your homework here. Start homework. Okay, I'll do the second part. This is going to be part 2 down here in a part 2 video. All right, but start your homework because you have enough skills now. And again, just use the summary here. Now you know how to tell by just looking at whether the function's either positive or negative and increasing or decreasing. That will tell you how the distance is changing. All right, and if the distance is either increasing or decreasing, meaning that's you're either getting closer to the pole or going away from the pole. And there we go. All right, I'm Mr. Aynesworth here. Hopefully that helped you out. All right, we're in 8.5 in AP Pre-Calc, and we are done with the course now. We're going to get started with mock exams. Oh yeah, so we're going to do some work after spring break. Actually, you guys are going to do some work during spring break, but we're going to be doing some mocks after. All right. I'll see you in my next lesson or in my next video and hopefully in class. Take care. Bye bye.